So we're going to look at the next part of our work on statistics. We have been introduced so far to the mean, median, mode, different types of averages. We also looked at different ways of measuring the spread of data, started off looking at the range, then we moved on to looking at quartiles and calculating the semi-interquartile range. We're now going to look at a new measure of spread, and that's something called the standard deviation. So again, lots of practical applications for using statistics. It's all about being able to collect data and then make use of it in some kind of practical format, and all the different careers there, people who might use statistics, engineers, scientists, data analysis, and so on. So we're going to look at what we might, why we might need to understand, a wee bit about why we need to understand what it is that we are actually working out with this. So measuring the spread of data, as I've already said, we've met two ways of doing that. There's the range and also the semi-interquartile range, and you have a formula for that. So why are we introducing another one to you? Because there's a little bit of a drawback with regard to both of these other types of measure. The range uses highest and lowest values only. Your semi-interquartile range, on the other hand, ignores the lowest and the highest value. Your range doesn't give any indication about where the majority of the values are, particularly if they're closely packed around the middle. Whereas the semi-interquartile range is actually, because it's going between Q3 and Q1 values, it is looking at the numbers that are in the middle. So what we're going to look at is the standard deviation, and what it does, the difference is it uses all the data. It takes into account where the bulk of the data lies, but it doesn't neglect the lowest and the highest values. So how does it work? So the steps to how we work with standard deviation are as follows. The first thing you will need to do with your data is work out the mean. So the mean is simply your total of all the values and then divide by how many values you have. In maths language, this is written down like this. So this little x with a bar above it, like a little line above it, is called x bar. That's the notation that's used for the mean. And this little almost kind of zigzag shape is the Greek letter sigma. And sigma stands for the word, it's short for the sum of all the x's. So we're going to be totaling all the values, and then the n is about dividing by how many values you have in your list. So for example, if you were trying to find the standard deviation of this group of numbers here, these would be this is our data set, these are our original values. So to work out our mean, we would simply add all those numbers up, which comes to, in this case, 78. To then work out the mean, I would then be taking that total and I would be dividing by 6, because you'll see there are 6 numbers in that list. That's going to give me an answer of 13. So the next bit is how we then go from there. So the mean you've met before, that's where you're totaling everything. What do we now do with that? And this is the bit that you need to remember how to do. We draw up a table to measure how far away each of the x values are from that mean value that we've just worked out, and that's this expression here, x take away x bar. So your table has got this second column. So you started with the x's, you now create this second column where you take each of these x's, and our mean value that we worked out a minute ago is going to be subtracted Now that results in some negative values and some positive values when we do this. And what we're trying to do is work out what's the average distance that each x is from the mean, and normally we would add those all up and divide by how many. However, if we add up that middle column there, we end up, you will see, with the value of 0 at the bottom here. So because that column comes to 0, we end up totaling we end up doing the squares of each of these. So this last column shouldn't have any negatives in it, it should all be positive. So that negative 10 squared, if you do this on your calculator, make sure you remember to use brackets. So brackets round it, negative 10 squared would give you positive 100, negative 4 squared you get 16, and so on. So that gets squared because that middle column would end up totaling 0, and that wouldn't help us in any way. So what we now do is find the sum of the last column, and that produces a value for, so this is us summing up. So the sigma bit just means the sum of all that last column is x minus x bar square numbers, and in this case that comes to 206. You are then, right, to calculate the average distance from the mean, you would normally expect to divide the total by n. However, statisticians have discovered they get a better value if they divide instead by n minus 1. You don't need to know why that is the case, but the formula that we get for working out the standard deviation, which is a measure of the spread, how far away are all the data points from the average point, from that x bar, from the mean point. And what you do is your values from your table, so that 206 is what's going in here, and what you need to write down is this. So there's the formula written down. You would replace the top line there with the value from the last column, and on the bottom we had 6 numbers, so 1 less than that means that we're dividing by 5. You do that on the calculator, and you get the answer of 6.4. Right, that's a rounded value. So standard deviation is a measure of how far all the scores differ from the mean. So what do? This is your steps to do this. You work out the mean, you draw up your table, and you're going to find the total of that last column, and then you substitute the values into the standard deviation formula. Now that is given in the formula list for National 5. So what is it that we're working out? Well, when you get a large value for standard deviation, so if it's a high value, it might be a picture like this bottom one here, where your data, all these wee green points represent data, where it would mean it was all quite spread out. If you got quite a low standard deviation value, it means that your values are all quite close to the mean, so it might give you a little picture, a bit like the one that you can see there. So that's how standard deviation has come about. What we now need to be able to do is to work with this in practice. So what I'll talk you through, there's the formula again, and this appears on your booklet, so you're going to need your booklet to hand. So just so you understand everything, the x's is the data values, the x bar is the mean, sigma means the sum of or the total, and n is the number of data points. And you're going to be drawing this table. You never ever get shown to do that. It's just there. It won't appear in the exam in the sense of they won't actually fill in a table. You're just expected to know that. And what standard deviation is a measure of how far away all the values are from the mean. So that's what this bit here is, x minus x bar. So remember that the bottom row is about summing everything. So to work out the mean, you total the first column and you divide by how many there are. and then you do the middle column, but then you need to square everything. So the best way for you to work out what to do is to look at this on your booklet. So you've got this example here, if you can be filling this in. So find the mean and standard deviation of these values. Now it doesn't matter how you write them into a table, but I'm going to say to you that you should draw this table up, hopefully using a ruler, and you list your x's, so your 2, 3, 9, 6 and 5, those are all your x values. You're then going to add those x values up, and if you add them up in this particular case, you will find that that comes to 25. Once you have got that total, the first thing you do is you're going to work out what x bar is, because you can't go any further. You need that information for the second column. So it's about taking the total. In this particular instance, if you count how many data points we've got, right, we've got 5 data points here, so we are going to be dividing by 5. So 25 divided by 5 means that the mean value is 5. Now I'm then going to use that mean value to work out, in this middle column, I'm going to take my x in each case. So here, that means I'm doing the 2, and I'm taking away the mean value, remember, is that 5 that I've worked out. So I'm doing 2 take away 5. Now that is going to give me, right, an answer of -3. Then I'm going to do the 3 that's there, and I'm also going to take away that mean value of 5, and that is going to give me -2. Then I'm going to be doing 9, take away the 5, and again that's going to give me +4. Then I'm doing 6, take away the mean value, which is 5, and that's going to give me the value of 1. And then I'm doing 5, take away that mean value of 5, and that gives me the value of 0. So having worked out that middle column from subtracting everything, I'm now going to square it. So I'm going to be doing -3 squared, and that -3 squared, make sure if you're doing this on the calculator that you know -3 times -3 is going to give you 9. If you do that, -3, and press the x squared on the calculator, you will find it gives you -9. So the way to make sure you get the correct answer is you need the brackets when you're doing this. So make sure you do that. So -3 squared, you need brackets around it. Same with -2 squared, that's going to give you +4. 4 squared, going to give you 16. 1 squared, of course, is 1, and 0 squared is just 0. I'm now going to add up all of those numbers, and all of those numbers totals to 30. So that is going to be, this number here is going to be the top number when I use the formula. And because I've squared everything, that's why we've got a square root symbol in the formula, because we're doing the average. But make sure that big tick, big square root, if you press that on your calculator and then press the fraction key, so you get all this information in the correct place. So the top of your fraction is 30. Bottom number of your fraction is about how many data numbers are there. So if you look at that, you'll see that we've got n equals 5 here. So what's going on the bottom is not 5, but n take away 1, so that's why it's 4. So we're doing the square root of 30 over 4. If I do that in the calculator, I'm going to get a decimal. It's going to give me 2.7386, whole load of other numbers. So I'm going to round that to 2 decimal places, and I'm getting standard deviation is 2.74, and that is it rounded to 2 decimal places. So make sure you understand how the table works. If you can construct that table, these are usually a 4 marks worth. In order to do that, you get 1 mark for working out your mean. You get another mark for all this work going on in the table. That's the second mark, is really for your table up to here. Third mark is for substituting into standard deviation, and the fourth mark is for the correct value. So there's a second example on your page there. This time, different set of numbers. We've got 6 numbers in the list this time. So again, you'd write those down: 4, 10, 8, 7, 3, 4. You don't need them in order. You can just write them down in the order that they are in the list. And you then total everything. So if you total all of those numbers, you'd end up with 36. And the first thing you do is you're then going to sub in here to work out the mean value. So x bar equals the sigma x, that's the sum of the x's, which is 36, over n. So n, remember, is about how many numbers are there in the list, and there are 6 here, so we are dividing by 6. So we're doing 36 divided by 6, which of course is 6. We now want to be taking that away from each of these numbers that we've got going on here. So we're going to be doing 4, take away the 6, which is the mean value, so we're going to get -2. Then we're doing 10, take away 6, which is 4. 8, take away 6, which is 2. 7, take away 6, which is 1. 3, take away 6, which is -3. And then 4, take away 6 is -2. So if you've done that correctly, that middle term will total to 0, but you can just leave that. You don't need to write 0 at the bottom of this. But what you now need to do is make sure that you do in fact square all these numbers. So -2 squared is +4. 4 squared, of course, is 16. 2 squared is 4. 1 squared is 1. -3 squared, make sure you put brackets around it, and -2 squared is +4. So again, we need to be adding all of those values. If you've added them all up, you will find that they come to 38. And we can go straight to our formula for standard deviation, and that number, the sigma x minus x squared, is what's going on the top of the fraction, so we're going to have 38. Our n number is 6, but we need 1 less on the bottom this time, so that would be 5. And if you do that on the calculator, you get 2.7568, all of the other numbers, and we would round that to 2.76. So we will be making use of this value to compare other sets of data, but for today you're just going to practice how we calculate the standard deviation, and it's important that you know how to deal with the tables.